Hello and welcome to this section of the course. We will be looking at graphs of cosecant, secant, and cotangent in this section. So, this video more interactive. I suggest you log into your favorite browser and bring up and type in your search engine Desmos graphic calculator. You should be able to find uh, this free graphic calculator where you can graph these for yourself. If you type in a letter CSC, that stands for cosecant of any angle given to you. Now I've added a few sliders. If you type in X first and put these values in front of it, so I'll show you briefly how you would get it. If you press X and if there is not a slider on your screen, you type in B and just choose an option to add a slider. So you will get such graphs. The dotted black line here is a graph of sine, which you can switch on and off here. And we want to explore how the graphs of functions are translated and stretched in different directions. So first of all, if we add anything inside the bracket, it will have an inverse effect. If we multiply anything inside the bracket, it will have an inverse effect. So increasing the value of b, actually, it will squash the graph, or rather stretch with the factor that is the opposite, or rather divide the x values by this factor b. So that reduce the value of b, the graph gets stretched, and usual position it should be number, it's just unit of 1. Now if we add anything, the graph add anything for value of c, make is c positive, the graph will shift to the left actually. So there is a counterintuitive move that some people have trouble understanding. I briefly try to explain that it's really the fact that when you add anything inside the bracket, it will shift the x and y axis to the right. So what you will see is the graph will be moving to the left. So, and if we subtract, make the value of c negative, it will have a positive, it will shift the graph to the right. So as I increase c more and more negative, the graph seems to be moving to the right. So I encourage you to explore and verify this for yourself. And D and A are outside the bracket, so they will have an ordinary effect. If I increase the value of D, it will shift the graph up, translate the graph up, and if I make the D negative, it will shift the graph downwards. And its usual place would be 0, because we wouldn't have any translations for the normal graph. Value of A will stretch the graph in y direction positively. So when I increase the value of A, I'm increasing the amplitude of the sine curve, and the cosec curve will have such movements as well, because cosec is the inverse of sine. So the most positive value of sine is 1, and the minimum of the graphs on top of the curve are 1. Okay, so you can play around with this. If you would like to see the secant function, you can type secant and cos, and they are similarly shaped to sine and cosec curves. And if you like to see cotangent graphs, you can turn on the cotangent graph, and what you notice is that if I move that around, uh, you will see that the tangents are actually, tangent and cotangent are such, they move in sync with each other in this manner. So I encourage you to play around with these and explore these translations for yourself. So let's go back to see how what we would be asked to do in some of these questions regarding graph transformations. So these are just some properties of the graph where the graph of cosec is asymptotes at 180 and 360 degrees vertical asymptotes, and, and at 0 degrees as well. So to sketch this graph, we know that there is a 1 outside the function added to secant curve, so it will translate the graph up by 1 unit, and the 2 in front of the theta will actually it will means that there is a stretch factor of a half. So the values will get closer to the zero or y-axis. So we will have two periods rather than one. If you think the sine periods will increase, sorry, the cosine periods will increase, and so will the periods of the secant curve. Okay, so as you see here, there are twice as many secant curves as we would normally have in 360 degrees. Right, so the next question is asking us to sketch the graph of 4 times cosecant. So 4 is outside of the function and it's a multiplicative factor. So it's a stretch factor of 4 in y direction. So where we would have a 1, now it would be stretched to number 4, and when we had the -1, it would be stretched to a factor of -4. Okay, and on the same graph, we've been asked to sketch the line of y equals to x. So if we do that, we'll get such a value where for pi will match up with pi, and that means that the y value here at this point would be 300, 3.14, and so on. So then the next part of the question is asking us how many solutions are there for this equation where 4 cosec x minus x is 0. Well, if we rearrange this equation, that's 4 cosec x equal to x, and that's actually the graph that we have already plotted. So is there an intersection between the red and the blue lines? No, there isn't. So therefore, there is no solution to this equation. Okay, with that, I'll leave you to practice, and I'll see you in the next section.